Hey everyone, welcome to this live session by Intellipaat. My name is Anirudh and I welcome you all to this session on how one can make a chatbot by using Python. Well guys, before we begin with this session, I hope you guys are all safe by social distancing and taking all the measures in quarantine and staying safe among this COVID-19 outbreak and keeping your learning up. Well, before we begin with this session, make sure to subscribe to the Intellipaat's YouTube channel and hit that bell icon so that you never miss an update from us. Alright, here's a quick look at the agenda today. We'll have a quick introduction to what chatbots are and why do we require it and much more. After that, we can check out the evolution of chatbots and we can give an overview on how chatbots work. And eventually, we'll take a dive into the steps which are required to understand how a chatbot works and how we can go on to build our own chatbot basically by showing you guys a very nice simple demo in Python. And at the end of it, as always, I'll be guiding you on the quickest way possible for you guys to become experts in Python. So make sure you stick till the end of the video because there's a small surprise at the end for all the viewers of this particular video. Well, on that note, let us begin the session. So let's begin this session by checking if you actually knew anything about these. So, did you know that whenever you talk to any of the customer services, customer supports, or any of the other tools out there, there is a 90% chance that you're actually talking to a chatbot and not a human being? Did you know this? Well, 90% of the time. So, let's say you respond or you communicate with certain companies, for example, like 10 times, out of which 9 times you're talking to an artificial intelligence powered machine and not a human being. Did you guys know this? Well, this is a fact, and I think this is amazing to begin with because whenever you are concerned with talking to Amazon, for example, Amazon is a very famous e-commerce site, as most of you would know. So you can leave them a message saying, hey, where is my order? I ordered, for example, this item, this mobile or whatever it is on this date, and I don't know where it is. So certain responses like this, instead of having a human reply to you, they can actually program in such a way that there is a chatbot sitting at the background, and this bot will basically have all the details about your order, and it can tell you where your order is, when it will reach you, if there are any delays, why there are delays, or much more. So for mundane tasks like this, this was just a very quick example for you guys. Chatbots have been implemented everywhere. For example, when you think about Netflix as well, even Netflix, for example, let's say your subscription was ending or something, and you just ping them asking, hey, I just paid, but my Netflix still says my subscription is not paid for. In that case, there is a chatbot which will actually reply saying, it takes 20 minutes or 30 minutes for your payment to be confirmed into our systems. And I mean, this happened to me just 3 days ago. So basically, I was working on chatbots in Python, and again I realized I was actually talking to a chatbot when I just went to watch something on Netflix as well. So that's just, I was saying, these are two very simple examples. 9 out of 10 cases you will actually be talking to a chatbot. For example, if you just check out the Intellipaat website, we have Alex is an AI powered chatbot as well. So basically, whenever you use the live chat option on the Intellipaat's homepage, you are actually talking to a chatbot as well, and it's a powerful chatbot. So if you haven't checked it out, make sure you check out after the video. Again, I'll be showing it to you at the end of the session as well. So if you want to check it out, make sure you stick till the end. So on that note, we need to understand what chatbots actually are. So as the name suggests, chat and bot has something to do with a robot imitating a person, while chatting to another person. So when we have to break it down into a little bit of simple terminology, basically it's a software which is based on artificial intelligence, and this software will try to imitate humans. It will try to basically, perform the same actions as us human beings without the person, having a very good idea if they're talking to a human being or an AI. If your chatbot is very good, if the chatbot which is being implemented is amazing, well, the human can be fooled enough to not know if they're talking to a robot or if they're not talking to a human as well. And most of the time, you wouldn't even require that kind of a complexity because let's say when you're in the Amazon case as well, where is my order or why has my payment declined or whatever it is, you will have a very simple question to which there will exist a straightforward answer, right? So it'll not like Amazon's chatbot will start telling you stories about why your payment failed or why your order didn't come or whatever. So when it comes to that, if it is very subtly implemented automated, if it is very complex in the back end, you will not find a difference between it being a robot or it being a human being as well. Way back in the 70s and the 60s, there was a test which was very famously implemented across the world. It's called as the Turing test. If you guys didn't know on that, make sure you read up on the Turing test. It was amazing on how artificial intelligence is such an old concept, but it's being used a lot in the 21st century. So whenever you think about artificial intelligence, ladies and gentlemen, the first couple of things that should come into your mind is, for example, Siri of Apple, Alexa of Amazon, or the Google Assistant. These chatbots again have been in our lives most of the time, right? For all the Apple users, you guys have Siri. For Amazon, we have Alexa, and for the Android phone mobile users, we have the Google Assistant. So you might have been using these on a daily basis, because one for sure, I use Siri a lot and I use Google Assistant a lot as well. And I do know people who use Alexa for their home automations and much more. So when it comes to stuff like this, from the simple Amazon chatbot all the way till a complex powered bot such as Siri, Alexa, or Google Assistant have been helping us daily. So in fact, you can ask the Google Assistant or Siri to play any song for you. And in fact, let's say you're sitting at a restaurant or something, you listen to a beautiful song that's being played, and you just want to find out what song it is. Instead of going through all the pain of installing a software which will listen to the song and tell you what song it is, or you asking the restaurant manager what song it is, just pop out your phone, say, "Hey Siri, what song is playing in the background?" Siri, or in fact even Google Assistant, will actually analyze the song, it'll listen to it, and it'll tell you, "Hey, this is the song that's being played." How simple is that? For example, you want to set a calendar invite for the next month, or let's say you have a meeting which you want a reminder for, you want to set an alarm. So all these manual tasks which you could do basically with one voice command, you can get all of it done very simply. And I think that's the essence of chatbots, ladies and gentlemen. So again, coming to emphasize on why we require chatbots, well, when you look at it, the first thing, it's cost and time effective for the companies, because developing a chatbot does not take a lot of money, and it makes sure that it can be done in a quick and a rapid way. As you'll see in the demo which I'll be showing at the end of the session, it will basically validate this point on how time effective it can be when we are working with chatbots, because it's pretty simple, it's pretty straightforward. And at the end of the day, even when you're working on an enterprise level, basically you're working at a level where you have a huge organization which requires a chatbot, it will not really cost much to build it as well. And of course, adding on to the last point itself, coming to the second point, it's cheap development cost. When you're working with chatbots, you need to understand that there are only certain things at this point of time that we can do with chatbots. Of course, with every passing day when we're talking about technology, there are again thousands and thousands of things which keep coming into the market. But with chatbots, you can have it respond, you can have it imitate a human to the best of its ability, right? And with the current power of AI, I think the entire world is pretty much just trying to make sure that their chatbots are as human as possible. So with cheap development costs, there are again a lot of companies which are jumping on the need of chatbots as well. So how would it help the companies, you might be asking? And the best thing is human resource. See, if you have a person who is responding to live chat, which is basically a mundane task, right? They keep doing it again and again and again. So this person as a human resource can probably put into a more effective role. This person can be put into a more productive role rather than answering the queries of customers, which can easily be done with the help of chatbots, right? So it's saving time, it's saving money, and pretty much it's increasing the productivity of the company as well. This is the primary reasons why thousands of companies across the world today have implemented chatbots. And the next point again adds on to the previous point as well. So since your company is being more productive now with the help of chatbots, again you can pretty much give that wow factor to your customers. And if it's not the wow factor, which is basically what you're looking for, you can help your business brand itself through all the social medias out there by showing the world, I've implemented artificial intelligence here. And you would invite the world, you would invite the developers, customers, or whoever it is to check it out and see if they like them, to see what's going on. And this again directly translates to you talking to your customers in a more customized way, and this will probably help your business in the short term as well as the long term as well, right? So it makes sense. So what do you think? I mean, there are millions of other chatbot cases that we can think of as well. For example, there are doctor apps and health apps which will basically diagnose any condition that you might have. So you can pretty much type in the symptoms and say this is what I'm facing, and it'll probably give you a very vague outcome of saying, hey, you might have this kind of a condition. Of course, you should consult an actual doctor and not rely on these chatbots at this point of time, but then we're getting there. Who knows, probably 10 years from now, the world of medicine can be revolutionized by keeping chatbots very accurate with respect to the field of medicine as well. And that's the thing about artificial intelligence, right? So when you think about it, the possibilities are actually endless, and we've started seeing those endless probabilities in the last 10 or 15 years or so. Coming to the next point, which is chatbot evolution. So this is one important concept, because when we talk about traditional chatbots, so all these traditional chatbots that we have seen all these days basically are system driven. So by system driven, what it basically means is that they have access to a small amount of data, and they have responses which basically they know what to reply for when you ask. For example, if you have to take the Amazon case again and simplify it to a level where there is a possibility is that the customer might ask two questions. The first question is, where is my order? And the second question might be saying, why is my payment failed? So when you have to break it down into simple terms, and the bot recognizes what question you might throw at it, giving the answer to it becomes very simple. So that was system driven. And automation scripts, as I just mentioned, if there are a certain number of questions which the business things that you can ask, they can program the answers automatically for this as well. And this relates to a minimum amount of functionality, because the chatbot cannot really think and grow and understand from what the customer asks. So it already knows the question, it basically maps that to an answer, and it just gives an answer. So it's basically a give and take policy where the bot might not be learning anything. And then coming to the current bots of today's world, these implement task level automation. So basically with task level automation, they know what they're seeing, and they can understand the context between the tasks and all of the system requirements that exist. So basically, if you're asking a question, the simple question again saying where my order is or why my payment has failed, it'll already have a system context there in place, saying this is the question, this is the answer, give the customer the answer. With task level context, it will know what task has to be done to arrive at that answer. So it's not like take a question, find the answer, give you the answer. So it's take a question, analyze, and then give you the answer. So with current bots, that analyze part that exists right now. So the communication level is intermediate. So probably 7 out of 10 times or 6 out of 10 times, you will not figure out that you're talking to a chatbot. So that's how interesting and intimidating it's become right now, that it's getting good. We're getting there. And customer help. Well, current bots basically have been put into a use of, for example, project support, customer service, front desk management, and much more. So if we have to talk about the future bots will have multiple levels of communication which are cross-linked with each other. What this means is that at the end of the day, when you are talking to a bot, you can ask the bot to get some task done for you. You can ask it queries and get questions. It can perform analysis for you and much more. And all of this coincides to one thing called a service level automation, basically, which will ensure that all the tasks which are to be done manually, all of these can be automated easily as well. So it understands system level context as the traditional bots, it understands task level context as the current bots we have in place, and the best part is it'll get people context as well. So it'll understand who you are, and it can start generating and recognizing patterns in between people, what people are requesting for, why they're requesting for, who requested it. So out of billions of people across the globe, if you keep asking and training your future bots on a certain number of questions, or you keep asking it something, it'll recognize that the question is coming from this particular person. So that's how powerful it can actually get. And of course, in the future as well, there are multiple concepts such as bot OS and master bots. So bot OS is basically an operating system which is completely revolutionized and revolving around the usage of bots for your use as well. And master bots are basically bots which can control a certain number of chatbots under them, and control some amount of context, some amount of functionality which are given to them to handle, basically. So they are the bots which will handle other bots, something like these. So something like this. So again, when we have to get a quick vivid comparison, I thought it was very vital for you guys to understand this about the traditional, current and the future bots as well. Going to the answer of how does a chatbot actually work? Well, there are two types of chatbots when you have to think about it. One is something called as rule-based bots and the other one is called as self-based bots. And the other one is basically self-based bots. So when you talk about rule-based bots, as the name suggests, there are some rules on which these bots will basically work on. You ask a simple question such as where is my order? Your bot will recognize the word where is and probably order. And this is a rule which is programmed in the backend which says when you find all these keywords, just give them an answer saying, hey, your order is here. Your order is on the way. Your order is delayed, whatever. So you cannot ask any complex queries to a rule-based bot because it will not have rules in the backend which will basically help it understand. So think about rules if they are like a book, all right. So it will basically look into this book for an answer. If it can find it, it will tell you, or else it cannot. So it's as simple as this. And most of the time, the training of these bots are really simple and it is not complex. And what this coincides to, it basically means that you can ask simple queries, get simple answers. If you ask complex queries, it might fail. And now coming to self-learning bots. Self-learning bots will make use of concepts such as machine learning. It will make use of concepts such as deep learning to basically understand what you're trying to tell the bot. It's not like there's a book, it will blindly refer the book and give you an answer. So it'll try to understand why you're asking this, what you're asking, and how best it can think it can give you the answer. So this line that I just said, this is very important for self-learning bots because this is exactly what makes it highly efficient, and it is basically a trick to learn and to basically fool you into thinking that it's a human being, and that of course is very good for us. That is what we're looking for here as well. But then training a self-learning bot will take a lot of effort because it is a very complex process to think about working with a lot of data. It will be terabytes worth of data for a very simple response generation as well. So training it with a lot of data, helping it analyze and helping the bot give us an answer based on an analysis rather than a textbook definition is something which is very complex as well. So these two are the basic types of bots which we work with in today's world. But then when we have to talk about self-learning bots a bit, because again, when you're talking about artificial intelligence, when you're talking about machine learning, there are again two more types of self-learning bots. So they're called as generative bots and retrieval-based bots. So let me talk about generative bots for a second here, and it's going to give you an answer. So basically you might be wondering, okay, so if I ask it any complex query, will I get an answer because it's using artificial intelligence? Well, the answer is no, because even though it can do word-to-word analysis, there are certain limitations here which will not allow it to give you an answer every single time. So in that particular case, generative bots actually have the upper hand when you think about retrieval based bots, because retrieval based bots are, again, they have predefined responses. So there are so you ask a question, it will go somewhere, pick up your answer and give it to you. So it's content based. So it's context based. With context based, it knows what you're asking, but it does not know. So it does not know how it can improvise its answer to basically give you the best answer out there. It knows that it can give you an answer, but it doesn't know how it can give you the best answer. For that, you need generative bots. Your generative bots will analyze the accuracy. It will analyze the likeness of its answer, and then it will give it out to you. So with self-learning bots, these are the basic examples. I'll quickly repeat it. So with generative bots, it knows and analyzes your answers before giving it out. With retrieval based bots, there are certain predefined responses where it just picks it up and it learns a little bit on that and then gives it to you. With generative bots, there's a comprehensive analysis which goes on with every single word that you put in, and then it learns. With retrieval based bots, it will look and hunt for a context, and once it finds that context, it will go back to the responses which are stored again, and then map those contexts based on responses and give you those answers as well. So on that note, next we'll have to check out something called as the chatbot chart. So basically, when you're working with a chatbot, right? So, there's a good chance you're either talking to the chatbot via messenger, you're communicating via website, or, you're probably using a mobile to talk to Siri, Alexa, or all of the chatbots that we discussed. So as a human, you will be giving it certain inputs and the chatbot will give you an output. So whatever inputs you give, right, so it will go into something called as a chatbot server. So the chatbot server will have three important things if you're talking about self-learning bots. So it'll have certain knowledge, and this is like the book that it will go on to hunt, and it'll have rules is basically like an index to the book saying this is where you need to look for the answers in the book. And then of course it'll have machine learning, it'll have artificial intelligence saying hey, learn to understand these rules and learn to understand where you can apply these rules to find the context in the knowledge. So it's something like that. And to do all of this, it needs a lot of data, right? So there are numerous data sources across the world. It can be something as simple as learning from Twitter, all the way to learning from certain studies, which is like probably 35,000 pages long or whatever. So everything from simple to complex data sources. It might be on the cloud, it might be social media, or wherever it is. Your chatbot server will pick up all of these data sources. It'll try to understand what knowledge can it learn based on machine learning and what rules it has to apply, so that it can arrive at this stage where it knows stuff. And then it's not important that it has to know stuff. What's important is that it has to find a way to convey all of this it knows in a human way, imitating a human, right? So that is again an important thing. So basically this is like a one picture one stop solution to understand the basics of how a chatbot would work. On that note, we can actually go on to building our own chatbot. To do that, there are certain things we need to walk through as well. And the first thing is prerequisites when you're working with Python. There are two amazing libraries, and two among, let's say, thousands of beautiful libraries of Python, because I'm a huge fan of Python for the reason that it has amazing libraries. So there are two main things which we will be using to build a chatbot, and it's pretty common and obvious as well. So we have scikit-learn, which is basically used as the machine learning library for Python, and there is NLTK. So NLTK is again another amazing library, as we'll be walking through step by step to understand what makes NLTK what it is. So it's an amazing natural language toolkit. That is what NLTK stands for, and it's widely used in today's world to ensure that they can make a very good chatbot as well. So to give you a quick revision of what NLTK is actually used for, so this natural language processing, this natural language toolkit is actually used to process certain human language data. Well, mostly it's English, because again, English is a widely used language. So it is basically used to understand how this chatbot can be built by making it understand the words. See, for example, you will know what an apple is, you will know what a ball is, you will know what a cat is. This is because from your childhood till today, you've been taught A for apple, B for ball, C for cat, or whatever it is. So you have been programmed over the years where you know what all of these are. But then as soon as your computer sees a cat, there's a good chance that unless it has any training, it is just a text which says cat. It will not understand that it's seeing a cat, or that the context is a cat. So to teach it that context, saying whenever I type a cat, you think of cats. So that aspect is basically where NLTK comes into play. And to do all of this, there are many concepts. There's classification, there's tokenization, there's stemming, there's lemmatization, there's parsing, and all of this. But to get to all of that, of course, we'll be checking out all of these. The first thing you need to do is you need to install NLTK. And to install NLTK with Python, there is a very simple command with pip, the package manager. It's pip install NLTK. And once you clear this step, you have NLTK installed and you can work with it. So coming to the terms that we have put down there, classification. So classification, when you're working with data, basically is where you help the chatbot understand what type of data it can see. For example, there are certain words which are used very commonly. They're called as stop words. So for example, the, is, that, was, all of these are stop words which will arrive, and you will be using it multiple times in a given sentence, right? So I might have used the word like 100 times or more than that in this live session as well. So you need to understand to classify what words are very commonly used, what words are not very commonly used, and more. And then tokenization. So tokenization is this process where each of your words are actually broken down into events and so tokenization is this process where each of your words are broken down into single entities, and these entities are called as tokens. Tokens are basically the input to the chatbot that you give, saying, hey, you know what, this is a word, understand what this means. And then coming to stemming and parsing, we're going to check this out in a bit of detail in a second now. So to make your bot understand text, the problem here is that your machine, when you're using machine learning, when you're using artificial intelligence, deep learning, whatever it is, it will require some numerical features to work with. It will require numbers, it will require vectors, it will require matrices to work with. It does not require strings, and with the help of strings it cannot learn. So how do we solve this problem? Well, let me tell you with preprocessing how basically the text preprocessing works. There are two things. One is case conversions and the other thing is tokenization. So again, before we delve into tokenization and case conversion, let me repeat why we are doing this. So when you're using machine learning, when you're using artificial intelligence, your bots or whatever you're building, it will require to understand zeros and ones. It will require numbers to understand, and it cannot work with text. So we need to find ways to convert our text into these numerical features, right? And hence we're doing the text preprocessing. Okay, so coming back to the methods. So there is case conversions and tokenization. With case conversion, for example, lower cases might mean different and upper cases might mean different. Let me tell you. So when you're starting out a sentence, you always start with an uppercase, but in the middle of the sentence, you will not be using any uppercase unless it's like a proper noun and certain reserved keywords, right? So your computer needs to understand this, and basically to do all of these, we will be converting everything into one case, usually when you're working with building a chatbot, because when you're thinking about keeping the same case and helping your machine teach, it becomes a very complex process. So to keep it very simple, we'll have the cases converted. So everything in a sentence will either be lowercase or everything in a sentence will be uppercase. So that's why we need case conversions. And when we talk about tokenization, as I just said, you'll be breaking down your sentences, your words into a list. So that's basically sentence tokenizers and word tokenizers. With sentence tokenizers, each of your sentences will be broken down into singular entities. With respect to word tokenizers, each of your words are broken down into structured entities called as tokens, and these form as the input. So when we have to talk about how it works in NLTK, we have something called as the NLTK tokenizer. And since we're working with the English language out here, so there is a pre-trained tokenizer which will already understand what you're typing in, and it's basically the pre-trained pumped tokenizer which is present as a part of the NLTK library. Alright, so one important thing you need to understand is that your text might contain a lot of things which is not required. For example, there are a lot of numbers or letters which you might not make sense of, or your computer might not sense of. So basically we need to remove all of these words, and this process is called as removal of noise, because this is noise through which it will not help us in any way building our chatbot. And then stop words, as I just mentioned, right? So is, was, and the, all of these are very common, very common stop words which need to be removed to ensure that your chatbot is not confused when it's working with words. So stop words have been removed, or they are pretty much categorized differently. And then stemming and lemmatization is where things starts getting really nice, because when you're thinking about stemming, so stemming is basically a word which is derived from its stem. So let me give you an example of a stem word. A stem word may be learn, Learn, learn. So when you're talking about stemming these words, think about the concepts such as learnt, learning, learned, learn. So these four words, right, which basically has something in common, which is Learn. You can have Learnt, Learned, Learning, learning. So learn is common in all of these words. So learn becomes a stem word through which you can give context to all of these other words, right? So that is stemming. Now talking about lemmatization is a little bit different from stemming, and here is why. Here we talk about context rather than the words itself. See, for example, if I tell you good, better, and best, it gives you a positive connotation and it gives you a general meaning of, something is good, right? So good also means it's good, better means it's good, best means it's good. So you need to make your computer understand that good, better, best all have a positive connotation and it means something is good in general. So lemmatization, all of these lemma concepts that we talk about is basically this, giving your context some meaning. So I hope I was clear with stemming and lemming. Stemming is where we use these stem words and basically, derive something out of each words, process, processing, processed, all of that. With lemmatization, it's basically context-based learning, good, better, best, where you're giving meaning to the words you're checking about. And then talking about the input to a chatbot, it's of course when it has to learn, it needs input, right? So basically, as I just mentioned, since it cannot understand strings directly, all of these strings are converted into numerics. So basically we are doing this by converting text into numerics based on their requirement. If they're required, they're considered. If they're not required, they're not considered. And you might be wondering why a concept like this is called as the bag of words. Why can't you just call it input? So it's called bag of words because here we're trying to consider the words which have come in. So we do not care about the order of words which come in. So if there is a sentence which says, I like Intellipaat, with the bag of words, think of it like you're dumping the words in the bag where you do not care about the order. For example, I like Intellipaat can become Intellipaat like Intellipaat I, or whatever order it is. So your sentence might not make sense grammatically, but all the words are there in a jumbled order. So it's like taking these words and putting them in a bag and jumbling them up, or even just putting it inside without any order. That is why it's called as the bag of words. And now coming into how it is basically processed. Let us take a raw input, and this raw input is something like a sentence which says, I do not like chocolates. Of course, there's not a lot of us who do not like chocolates, right? So ladies and gentlemen, again, let's keep this session interactive. So head to the comment section and put in your comments so we can understand and help each other out better here. So again, coming back to this, with respect to raw input, it's let's have a sentence which says, I do not like chocolates, and you want your computer to basically understand I like chocolates part of it. So I do not part, we do not want it. Are you getting it? So your input is I do not like chocolates. You want your machine to pick up I like chocolates, and this is how it does. So I is required, so it becomes 1. Do not is not required, so do becomes 0, not becomes 0, like is required, like is 1, chocolates is 1. So whatever words you want to be picked, those words are 1, and whatever words you do not want it to be picked, those become zeros, right? So this is how, in a very, very simple way, it's called as vectorization. And of course each of these entities will be separated by a comma, but then just to keep it more readable for you guys, I'm just showing you a general way on how an input can be vectorized and what is the result that we can obtain by converting this grammatically correct or incorrect sentence, for that matter as well, into a mathematical vector. Alright, so I hope this is clear. And with that, we need to check out something called as the TF-IDF formula. So guys, again, if you know what TF-IDF is, head to the comment section and let us know. So what is a TF-IDF? Well, it's actually an acronym for term frequency and inverse document frequency. Well, fret not if you don't know what this means, as I'll be explaining all of this. So with respect to bag of words that we just discussed, right? So when you have an input which is a bag of words, it'll have a lot of words. So basically I told you we are ditching the order and we're just considering a lot of words, right? So that is the advantage and the disadvantage. The advantage is that there is a lot of words. The disadvantage is that, your bot will not have a lot of information there. So there is a difference between having a lot of words and helping your bot understand all of these words, right? So this is where bag of words has a little bit of a downside which can be fixed. And it's fixed by, giving it context and making it understand about these words. And to do that, we have something called as term frequency and inverse document frequency. So let's talk about term frequency before. First, basically, term frequency, when we're working about it, you need to understand that we need to find out how many times the term is occurring. So this might be because of classification. We need to understand stop words. We need to find out how many times one word is occurring. So if you have a sentence which has the word apple like 100 times, let's say it's a 10,000 word essay and you've used the word apple 100 times, you know it because probably you have used it. Now to make your computer understand that there is apple there 100 times, we need to to find out how many times it has occurred divided by how many total terms there are in the document, right? So this will give you a term frequency saying, for example, if we do 100 by 1000, so there is a chance that 0.1% of every single time your word apple is occurring. So if you have like 1000 words which says apple 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 1000 times, and then if you want to search the term frequency of apple, what do you think it is? So it's going to be 1000 itself, right? Because there is nothing else in that. So I'll give you an example again in the next slide. You will get a lot of clarity on this as well. For now, you need to just know that the formula of term frequency, where we are trying to find out how many times a term occurs, is basically the number of times it appears in a document divided by the total terms in that document as well. Now if we talk about IDF is basically inverse document frequency. So inverse document frequency is the number of times that your word has not occurred. What is the rarity of words that has basically occurred in your document as well? So for that, we'll be using a logarithmic formula. It's basically 1 plus log of x by y, where x is the number of documents that you have where you're checking this, and y is the number of documents where this term occurs. So when you do a logarithmic inversion of this number of documents by the number of occurrence of the term, you will get the rarity of how many times the term has not occurred there. So let's walk through this with an example. On the left, I've kept the formula so that you can refer to it while we calculate on the right. So let's say right now we have an essay, or we have a document which we also call as a corpus. So corpus is basically the input document. So let's say we have a document which is 500 words, and in this 500 words the word call appears 10 times. All right, so this is a generic document, there is 500 words and the word call appears 10 times here. So what does the term frequency of this mean? So term frequency again is the number of times a term appears, which is 10, divided by the total words, which is 500. So 10 by 500 will give a term frequency of 0.02. So for every word that you have written in this document, there is a 0.02 times chance that you've used the word call. This is term frequency visualized. And then if you have to talk about IDF, consider this. Let's say there are 10 lakh documents out there, and the word call now appears in just 60,000 of these 10 lakh documents, right? So 10 lakh documents, the word call appears in only 60,000 documents of these 10 lakh documents. Now to find out the inverse document frequency, basically as I just mentioned, we're going to take the 10 lakh, which is the number of documents, total documents, and divide it with the documents where we have the term which we require. So IDF in this case becomes 10 lakh divided by 60,000, which gives us a value of 1.22. And now if you have to give context to your machine, if you have to tell your machine, hey, this is the word, this is the context, this is how many times it occurs, there's something called as TF-IDF weight, and this weight is basically the product of term frequency and the inverse document frequency here. So as soon as we multiply all of that, we'll get a number which is 0.0244, and this number will basically give context to your machine, saying this is the weight of this particular term in these documents and in each of these particular documents as well. So your word in every document, in total number of documents added together, clubbed, and after you find the term frequency and the inverse document frequency, you will arrive at the weight of it. So on that note, we've seen all of these theoretically, and we need to now check it practically. So let me quickly jump to the practical aspect of how we can go on to check it. So here I am making use of Google Collab. Google Collab is basically a Python Jupyter notebook which is hosted on their Google Cloud platform. So this is where we will check out a very simple demo use case of how we'll go on to work with chatbots by using Python. Here again, as we have walked through in the theory, we'll be making use of NLTK. NLTK is the Natural Language Toolkit, which is a beautiful library to work with when you're thinking about Python. And of course, as always, whenever you're working with Python, it is a common practice that you import all the libraries that you require at the start of it. So in this particular case, we are importing NLTK and NumPy because you have to work with numerical computations. We're importing random because we'll be randomizing a couple of aspects here, and we're importing string. So string is basically a library which will help with string processing techniques in Python as well. So if you are on a native Python environment which is different from Google Collab, you might have to install all of these before using it. To do it, instead of import, just type pip install, pip space install space nltk, pip space install space numpy as well. So with Google Collab, all of this comes pre-installed, and that's the reason all we have to do is we have to just import them and it starts working. So after importing all of the libraries, the first step is to make sure that there is some data through which we can teach the chatbot, right? So this is where we'll have a file. This file or this document is called as a corpus, and with this document, this is where all the data resides in which your chatbot can understand. All right. So to do that, first we'll be using the file function. We'll be using an open function where the file we have, we'll call it as chatbot.text. Of course, you can call this anything else you want. You'll be opening it in the read mode because you're reading it, and if there are any errors, we're going to ignore those errors for now. So after reading this document, we'll be converting it to lowercase because, as I told you, case conversion is very vital for data pre-processing, and we will download the punked part of the toolcase because we're working with English language, and this is already a pre-trained library that is present, right? So this is a one-time download that you'll have to do. And of course, we have something called as WordNet. So WordNet is basically a database which consists of relationships in between each of these words, all right? So with WordNet, you will have an access to like 200 languages. With respect to Punkt, it will give you the pre-trained library for English as well. And in fact, the WordNet is it's a pretty old library of data. It is present with us from the 1980s as well. So that's a fun fact for you guys. And now we spoke about tokenization as well, right? So we need to tokenize this to be each inputs of words and be inputs of sentences. So basically we are using nltk.sent_token to basically convert the sentences from the raw data, and word_tokenize to basically convert words. So here sent_tokenize is the sentence tokenizer, word_tokenize is basically the word tokenizer. All right. So again, as you can see, if you just put your mouse on that, you will basically find out what it is. So you can actually go on to the definition of it and find out about it a little bit as well. So now to do this, we need an input. So we haven't yet talked about what input we are doing, right? So in fact, let's go to a Wikipedia page and give chatbot. So there is a Wikipedia page called Chatbot, and this is like a basic input to our model to train. So what we'll actually do is we'll take everything here, just hit Control A, in fact copy all of this and basically put it to a file, create a file called as chatbot.text and just put all of this there. So you will have something like this, and this is like a text file through which your chatbot can learn something. All right, it's simple as this. After that, save it, call it whatever you want, but then you have to remember the name because you have to input this, right? So now coming back to the input, as soon as I hit play, now it's going to say an error because it does not know where my chatbot.text is. It's on my desktop and we're running it on the Google Cloud. So let me quickly upload the file here, chatbot.text, and as soon as this is uploaded, I can run it again, and now it sees my chatbot.text file. It will convert everything to lowercase. It will download everything that's required. It will convert it into sentence tokens. It will convert everything into word tokens. So we did all of this by making use of 5-6 lines of code, and it's this simple, guys. And now coming to the next aspect of the same step 2, basically here is where we'll be printing an example to see our sentence token and word tokens to see if it has worked, right? So now as you can see, I just hit print and we're trying to just print a sentence token here, and we're trying to print a word token here as well. So whatever sentence here, you can give any sentence for checking here, and then you can just paste to see if this this sentence, which is the raw input, if it is converted into a token or not. So as soon as I hit play here again, it is obviously converted into sentence tokens and word tokens as well. So coming to the next step is basically pre-processing and handling your data. So as I said, WordNet is basically like a dictionary out there with more than 200 languages, and where it understands your words. Now we discussed about lematizer. With respect to lematizer, we give this word certain context, right? So that's basically what we're doing out here. With lemmatization, we are giving it context. You can think of the example which I just mentioned, good, better, and best there as well, right? So basically step 2 is all about that. And then coming to step number three is basically where you will be programming a greet response. See, for example, with any chatbot, right? Be it Alexa, be it Siri, be it Google Assistant, whatever it is. As soon as you say hi or hey, it will not tell you something which is very vague. It'll greet you back. It'll be very nice to you and it'll say, hey there, what's up? Or, how's it going? Whatever it is. It's like a human conversation. So when you say hi to someone, they'll not just nod their head. 90% of the time, they'll say hi back to you, right? So to give it that human touch, step three is all about giving greeting inputs and responses. So if you give it a response saying hello, hi, greetings, sup, what's up, hey, or whatever it is, it will give you a response back with hi, hey. It'll nod its head. It'll give you hi there, hello. It'll say I am glad you're talking to me and all of that. So you can change these inputs and these responses to whatever you want. So basically, this is not very complex. If it sees any of these, it'll give you a random input of this. This is where we require the random function that we inputted, right? So you might be wondering where it's not like you give hello and it tells you hi every single time. You can say hello 10 times and it'll give you 10 different outputs from this response here. So as soon as we run this, we are taking the inputs and we're generating random greeting responses and printing to the screen. Now, coming to step number four is where we start giving out responses. So to give out certain responses, so you need to understand that we'll be using the TF-IDF concepts. So I hope you guys remember the term frequency concept, the inverse document frequency there. Now we have to import all of these, right? So basically these are all part of scikit-learn. It's part of the concept called as the feature extraction, which is based on textual inputs. So we're going to import that, and you might be seeing the second thing which is being imported here as well. So the second thing which is imported is something called as cosine similarity. So cosine similarity is a part where you'll be checking out and teaching your chatbot about how to find certain behavior inputs and how to find and understand what your difference is and the similarity is in between what the user types and in between what document is present. Do you understand that? So in our case, the document is the Wikipedia article that we took up, and the user input might be something where it has to learn and map this user input to the document. So that is where cosine similarity is used as well. Of course, we can discuss the TF-IDF concept or cosine similarity in a lot of depth. But then I do not want to overwhelm you guys with loads of information here, alright? So we're trying to keep it simple, and as you can see, it's just a couple of lines and we have almost built our chatbot. So after generating these responses, we need to write a function for concepts such as where we are thinking of stop words, we are pretty much removing all these stop words, understanding it, and we haven't talked about what happens if your chatbot doesn't understand you, right? So if it sees stop words, it knows what to do. If it sees a greeting message, it knows it has to greet you back. But then if you type random stuff there, it has to give you a response, right? So it cannot stay idle. So basically we are trying to print a message here saying, hey, I'm sorry, I do not understand whatever you have typed. So with respect to this function, it's pretty straightforward. It's pretty easy. If it doesn't understand something, it'll tell you it doesn't understand you. And step 5. Yes, step 5, or probably we can call this step 6 as well. So this is the last step where you will be programming the start point and the end point. So starting when you run the chatbot, instead of greeting it, it will probably say, hey, my name is this, I can help you with this, and I want to quit. No, and if you want to quit, just type something, type bye-bye or whatever. So in fact, there's actually a tiny mistake here which I will clear, which is a spelling mistake which is can. I mean, come on, everyone does spelling mistakes. All right. Now, so basically what I'm trying to tell you guys here is that as soon as your chatbot starts working, it'll print out this message. It'll say, chatbot, hi, my name is Samplebot. I can help you with chatbots if you need. This will be anything else, because we randomly picked a Wikipedia article for chatbot. You can pick up anything. It doesn't have to be a Wikipedia page. You can make it learn on a blog of your choice and then give you responses to the questions you ask. And then if you want to come out of the loop, this is basically working on a while loop where it's constantly waiting for your input. If you want to quit, you can just type bye, and if it sees a bye in the input section, it'll say thank you or thanks, and it'll basically quit. So as soon as we go ahead and run this, it says chatbot, my name is samplebot, how can I help you? If you want to quit, type by anytime. So let's say hi to our chatbot. It'll say hey. Again, as I mentioned, it is a random response that it is giving to us based on the greeting pool, right? So I can say hi again, and it will say something else apart from hey. So it says hi there. Another time, let me say like hey or something, it'll say something else. So as you can see, it's not giving you the sample a response that it is supposed to give. So it is generating random responses and it's giving it to you out there. Now let's just say we want to quit. All you have to type is bye, and as soon as it says bye, it's like, okay, thank you for talking, bye bye. And it's pretty simple like this, right? So even this we achieved with like 5 or 6 simple steps in Python, which is really amazing. And in fact, let's run again. So in the chatbot article, there's this person called as Alan Turing, who is considered to be the father of intelligent machines. So let's ask the chatbot, who is Alan Turing? Let's see if it can find that out. Of course, the responses will be pretty vague. It will not be very accurate. It says there is a stop word which came here as well. Of course, apart from that, it gave you the answer. It says Alan Turing was a British scientist and he was a pioneer in computer science. See, I asked it a question saying, who is Alan Turing? It figured out that I'm asking a who question. It found out everything about Alan Turing and it gave me a sentence output there saying Alan Turing was a British scientist and a pioneer in computer science as well. So basically, this you might be expecting like a 2-liner, 3-liner output, but our chatbot, this simple chatbot, is intelligent enough to find this for you, and it's amazing. So basically, we didn't write hundreds of lines of code here. We probably wrote like 100 lines in total, or less than that, in fact, to build our own chatbot to do this, right? So it's as important as this, and it's as fun as this. So we can check out a case where it doesn't understand. So if I go on to type some random stuff, it'll say, so see, I'm sorry, I did not understand you. So this pretty much covers all of the cases. We checked out greeting, we've generated a response where it does not understand you, and it pretty much analyzes your document and gives you a valid response of whatever is in the document as well. So you can type something else as well which is not in the document, and it will say I do not know, because it has not gone through these words in the document there as well, right? So again, pretty simple, and I hope this demo was pretty much understandable to all of you guys. So there are many other complex demos which I can use and show with respect to NLP, probably by making use of very very complex data, and by creating like a very nice use case, by making use of a very nice user interface, by using TK inter and whatnot. But then again, to keep it simple, so this was what I had in mind. Now anyway, coming back to our presentation, the next thing that would come into my mind is, of course, my final thoughts. And at this moment of time, guys, since we are in quarantine, again, I'm reiterating the first point which I started off with the session. Let's all be safe in quarantine. Make sure you are having some social distancing, and you have to understand the first point here is that with this, let it not hinder your daily life. If you're a student, if you're a working professional, you have everything at your house to basically upskill yourself, right? So probably at the start of January, you might be saying, hey, 2020 is my time. I want to become an expert in Python. I want to become a data scientist. Whatever you thought of, then you might be like, okay, the COVID-19 happened, so what do I do? Well, fear not, because with everything going on, you have internet, you have your computer, you have your mobile phone, you have a laptop, and a good a working environment at your home as well. So all of this you already have. Make sure to make the best use of this. Stay safe, take every measure that's needed, and make sure you work on your IT dream at the same time. So that's my final thoughts, guys. Now coming to further learning, this is one amazing quote from Benjamin Franklin which I always champion because I really like it and it's very strong. Let's say this. So an investment in knowledge always pays the best interest, right? So you can invest your money anywhere you want, and there's a good chance you will not have a return as much as what knowledge will give you. So it's always worth to spend your money, spend your hard-earned money on getting more knowledge in a structured way, in a professional way, and this will always help you. And as Benjamin Franklin said, this is the best interest provider out there as well, guys. So anyway, coming to further learning concepts, we have multiple videos on all of the IT concepts on our comprehensively put together YouTube channel. So make sure you check out the YouTube channel, make sure to subscribe, hit the bell icon so that you're notified when you want some content or when we put up some content there as well. So again, so if you have any content requests, right guys, head to the comment section now and let us know there so that we can work on the content and we can provide it to you as well. Now coming to the blogs aspect of it, we have Intellipaat blogs, where again, so blogs are put together by our experts. It is written by software architects, researchers, and if you're not much of a video watching fan, you can always check out blogs as well. And of course, we have the Intellipaat community where we discuss anything and everything IT. We have people across the world helping each other out, from the simple queries to all the complex programming queries one might face problems by. So make sure you visit the Intellipaat community, our YouTube channel and blogs, and see where your learning can be put to maximum use as well. So on that note, let me quickly show you the fastest possible way of becoming an expert in Python. As I mentioned that, in fact, we are giving away a free self-paced program at Intellipaat right now. Yes, it's absolutely free. So all you have to do is get to intellipaat.com/Python certification training online. Make sure to hit your email ID and your phone number and click on the get free course, and you will have access to a free course there as well. And the second thing that I mentioned, we told we have Alex, basically, who is the chatbot at Intellipaat, right? So you can see this is Alex working here. So Alex says, hello, welcome to Intellipaat. How may I assist you? There's 150 plus courses running amazing offers. So basically you can talk to Alex here, and Alex will guide you with respect to your courses, in case if you want like the easiest way to talk to someone as well. So now coming to Python certification course training, this is one of the very well reviewed courses at Intellipaat. It has almost 9,000 learners, and there's a reason there's a 5-star rating on our course, because we're covering everything in detail. All of the modules, say SciPy, Matplotlib, Pandas, scikit-learn, NumPy, web scraping, Lambda functions, and even a little bit about big data as well. So with this, you'll be getting 42 hours of instructor-led live training, 24 hours of self-paced videos where videos are recorded and you can watch it later, and then there's 50 hours of project work, because this at the end of the day is what matters, right? So on your resume, you're gonna put out these project work, and probably to new hirers and whoever is trying to hire you, or whatever you're trying to make use of through the certification, it's going to be your knowledge, it's going to be a career, or it's going to be on your resume to get your job, right? So project works and exercises are extremely vital, and you get 50 hours of those as well. Certification and job assistance alongside flexible scheduling are some of the highlights, and the most important thing is you get lifetime access, lifetime free upgrades, and of course lifetime 24/7 support with the courses as well. Now coming to the Python course content, basically everything from the basics of Python, setting everything up and understanding the basics, basic constructs, learning the OOP concepts. OOP is basically object oriented programming, the database connection, how you can work with NumPy libraries such as SciPy, Matplotlib. Matplotlib is a beautiful library for data visualization, Pandas for data handling, exception handling, multi-threading and handling race condition, packages and functions, web scraping, and Python for Apache coding as well. So as you can see, I can just keep scrolling, and there is a lot of things that you can actually take out. But then if you have to take a detailed look at what we're covering in this course content, make sure to hit the download curriculum button, and here you can have the entirety of the curriculum in a single document where you can have a detailed look at it as well. And then scrolling further basically will give you access to the projects you'll be working on. These are industry level projects. This is the general industry. We have a project from the telecommunications industry here as well, and we'll be performing some web scraping and much more. So all of these projects will help you strengthen and basically and add concrete validation to all of the things that you have learned. And of course at the end of the course you will be given a course certificate which will look like this, and this certificate is very well recognized in the top MNCs across the world today, be it Ericsson, be it Cisco, Genpact, Hexaware, Mu Sigma, Sony, Cognizant. All of these guys prefer candidates who are certified from Intellipaat as well. And scrolling down, you can see all the feedback that our learners leave us. You can check out about the course advisors, and at the end of it we have the FAQ section, which will basically cover a couple of questions you might have. And we understand that you might have more questions for us, and before that, just give me a second to fulfill my promise which I made at the start of the session. Here is a coupon code to all you learners. It's YouTube 30, YOUTUBE in caps and 30 in numeric. Use this coupon code to get flat 30% off on all of the courses we sell here at Intellipaat. This is basically Intellipaat's way of helping everyone among this quarantine. So make sure you use this code as soon as possible, and I'll just give you the details of that as well. On that note, basically, if you have any questions, any suggestions, or if anything is not covered in our FAQ section and you have to ask those to us as well, make sure to go to the comment section and leave us a comment there. Our team is there waiting to help you out. But then if you're looking for a course, or if you want some help with respect to any of the courses or anything on Intellipaat's website in general about your career or whatever it is, we have our course advisors who are here 24/7, 365 days of the year. So make sure you give us a call at the numbers you see on your screen. There's an Indian number and the US number right there. And of course, if you want to write us a mail, you can always shoot us a mail, sales@intellipaat.com, and our experts will get back to you at the earliest. On that note, you have reached the end of this session. As always, I'm more than excited to see you on the next one. Have a nice day ahead.